This is section 2.2. It's on conditional statements. This will be our third video. Last time, we talked about writing a converse and an inverse and a contrapositive if we had a conditional statement. We also talked about their truth values. So the statements that are equivalent are the conditional and its contrapositive. They're either going to be both true or both false. Similarly, the converse and the inverse of a conditional are either both true or both false. Those pairs of statements, such as these, are called equivalent statements. In general, when two statements are both true or both false, they are called equivalent statements. So if we go back up to this example, if the measure of angle A is 99, then angle A is obtuse. That's your conditional statement. That's true. If angle A is 99, then angle A has to be obtuse. Now, when you form the converse, you're going to switch the red and the blue, but you're going to keep if and then where they are. So it's going to look like this. If angle A is obtuse, then the measure of angle A is 99. That is not necessarily true, so we would put false for this one. If you have an obtuse angle, it doesn't have to be 99 degrees. Now that you know the truth values for both of these, you automatically know the truth values of these. So if you struggle trying to figure out what they mean, just remember, the converse and the inverse mean the same thing. So if this is false, this is false. The conditional and the contrapositive mean the same thing. So if this is true, this is true. Okay, so the inverse, remember, is the negation of the conditional. So it would be if the measure of angle A is not 99, then angle A is not obtuse. Remember, it has the same truth value as this, so this is not a true statement. Okay, but the contrapositive would be. The contrapositive is the negation of the converse. So if angle A is not obtuse, then the measure of angle A is not 99. That means the same thing as this statement. The other reason we study this type of thing in this class is for definitions. You can write a definition as a conditional statement in an if-then form or as its converse. Both the conditional statement and its converse have to be true. For example, consider the definition of perpendicular lines. If two lines intersect to form a right angle, then they are perpendicular lines. The definition can also be written using the converse. If two lines are perpendicular, then they intersect to form a right angle. Good definitions are reversible, meaning it means the same thing forwards as it does backwards. The conditional and the converse both have to have the same truth value. So if you can reverse a statement, it's a good definition. We're also going to see many biconditional statements in our text. That's when a conditional statement and its converse are both true. You can write them as a single biconditional statement. A biconditional statement is a statement that contains the phrase if and only if. So when you see that magic phrase, that means that the statement is automatically true forwards and backwards. Any valid definition can be written as a biconditional. It doesn't have to be, but you could do it if you wanted to. It's reversible. That's what that means. So here's our definition. If two lines intersect to form a right angle, then they are perpendicular. Converse, if two lines are perpendicular, then they intersect to form a right angle. Biconditional would be, say the blue, say if and only if, then say the red. Also, you could say the red first, if and only if blue. It means the same thing because it's reversible. Two lines are perpendicular if and only if they intersect to form a right angle. To abbreviate if and only if, we write the word if with an extra F. So when you see that, it's not a typo. That means if and only if.